Hello everyone. Today we will start numerical solution of algebraic and transcendental equation. So first of all is today we will discuss bisection method. So before going to this, first we have some introduction. In applied mathematics and engineering, we frequently face the problem of finding one or more roots of an equation fx equal to 0, where fx is in general a nonlinear function of real variable x. But in most cases, it is very difficult to have explicit solutions of the equation 1, and therefore we proceed to look for a root of equation 1 numerically with any specified degree of accuracy. The numerical methods of finding these roots are called iterative methods. So first is algebraic nonlinear equations. Algebraic equations of degree other than 1 are called nonlinear equations. As for example, x cube minus 5x plus 4 equal to 0, x to the power 4 minus 3x square minus 4x plus 6 equal to 0, root x plus 3x square minus 5 equal to 0. Next is transcendental equation. The equations which have infinite number of terms are called transcendental equation. As for example, 1 minus 3x plus 4x square plus 6x cube infinity equal to 0. Or we can write x cos x minus x plus 1 equal to 0, x e to the power x minus 2 equal to 0, x square log x minus 3x plus 2 equal to 0, etc. So we know that is in trigonometrical like terms like sin x, cos x, tan x, and exponential term x to the power x and log x also have an expansion in infinite series. For this reason, the equations that contain trigonometric, exponential, and logarithm terms are also transcendental equation. So both the algebraic or transcendental equations in general may be represented by fx equal to 0. Next is roots of an equation. If fx equal to 0 be an equation and alpha be a value of x such that f of alpha equal to 0, then alpha is a root of an equation fx equal to 0. Example, consider the equation x cube minus 5x plus 4 equal to 0. Therefore, fx equal to x cube minus 5x plus 4 equal to 0 and f1 equal to 0. That means 1 is the root of the equation x cube minus 5x plus 4 equal to 0, because that point 1 satisfies the function, satisfies the equation this one equal to 0. So that's why we can say 1 is the roots of the equation x cube minus 5x plus 4 equal to 0. Next is fundamental theorem of algebra. The statement is every algebraic equation has at least one root and nth degree equation has exactly n roots, which may be real, imaginary, and complex. Next is iteration process. Let the sequence xn of iterates of a root alpha of the equation fx equal to 0 is produced by a given method, and the error epsilon n involved at the nth iteration is given by epsilon n equal to alpha minus xn. If epsilon n tends to 0 as n tends to infinity, we can say that iteration converges to alpha. Otherwise, the iteration is divergent and the method of computation fails. So our primary task is to find the condition of convergence of the iteration process. So in this case, when the iterative method converges, we can find two parameters. One is P, another one is Q. P must be greater equal to 1 and Q must be less than 0. And the formula is limit n tends to infinity epsilon n plus 1 by epsilon n to the power p equal to q, where p is order of convergence and q is asymptotic error. If the iterative method p greater than 1, that means it converges rapidly. Next is another theorem. This is very important theorem. Actually, depend on this theorem, we will discuss few methods of to solve the transcendental equation. So this theorem is very important because um, uh, methods are depend on this theorem, and repetitive application of these theorems are here applied. So the statement is, no need to prove. If real world function fx is continuous in AB and f of A, f of B are of opposite signs, then there is at least one real root of fx equal to 0 in AB. Methods of finding accurate roots. So in this syllabus, in this chapter, we will discuss three important methods, which are: the following computer-oriented methods are used to find an accurate real root of the equation fx equal to 0. Bisection method, Newton-Raphson method, another name is method of tangent, regular false method, method of false position, or method of chord. So today we will discuss first bisection method. So what is bisection method? Already I told you, bisection method is repetitive application of the above theorem. So in this iterative method, it is based on a well-known theorem which states that if fx be a continuous function in AB and f of A into f of B, this one, f of A into f of B less than 0, then there exists at least one real root of the equation fx equal to 0 between A and B. It is known as half interval or Bolzano method. This method is nothing but a repetitive application of above theorem. So now we shall determine a sufficiently small interval a0 b0 in which a0 b0 in which f of a0 into f of b0 less than 0 and f dash x maintains the same sign in a0 b0, so that there is only one root of fx equal to 0. Just see here a to b interval. So for point the a, here we have positive value and here we have negative value. So f of a0 into f of b0 less than 0. So f dash x maintains the same sign in f0 b0, so that we can say there is only one root in fx equal to 0. Now we shall find a sequence xn, each element of which is a successive better approximation or root, say alpha of fx equal to 0 in a0 b0. So let the interval a0 b0 is divided into two equal parts, x1 equal to a0 plus b0 by 2 and f of x1 calculated. If f of x1 equal to 0, that means x1 is an exact root of fx equal to 0. If f of x1 not equal to 0, so we can say root lies between a0 to x1 or x1 to b0. Suppose we are taking f of a0 into f of x1 less than 0. That means root lies between a0 to x1. Otherwise, we can say root lies between x1 to b0. So our convenience, we assume that root lies between x1 to b1, x1 to b1, x1 to b0. So we are taking root lies between x1 to b0. So here we rename the interval b0 as b1, b0 as b1. So interval is x1 to b1, and here rename it also A1. So root lies between now. Rename the interval. After renaming the interval, root lies between A1, B1. Okay. So now B1 minus A1 equal to B1 means B0 and A1 means X1. X1 means A0 plus B0 by 2. Here we have taken. So here B1 minus A1 equal to half of B0 minus A0. Okay. Now we take x2 equal to a1 plus b1 by 2. Again f of x2 calculated. So either x2 lies between, either the x2 after the point lies between a1 to x2 or x2 to b1. A1 to x2 or x2 to b1. That means either a1 f of x2 less than 0 or f of x2 f of b1 less than 0. Okay, so we assume that we are we are taking that root lies between a1 to x2. Okay, so we recall it the interval as a1 as a2 and x2 as b2. Just rename the interval. So new interval is a2 b2. So b2 minus a2 equal to b2 means a1 plus b1 by 2. A2 means a1. Again we know that a1 equal to x1. x1 equal to a0 plus b0 by 2. So after simplifying, here we have 1 by 2 square b0 minus a0. Okay, so proceeding in this way, so we will get xn plus 1 equal to an plus bn by 2, which is the n plus 1th approximation of the root alpha of fx equal to 0 and lies in the interval an bn, and where bn minus n equal to 1 by 2 to the power n b0 minus a0. And here the convergence of bisection method, since epsilon n plus 1 divided by epsilon equal to half, so here the convergence is linear. No need to prove, just we should remember this line. So this is the convergence of bisection method is linear. Next is advantage and disadvantage. So advantage is the method is simple, easy to implement and unconditionally convergent. Disadvantages are the disadvantage of the method is very slow as it is based on the halving of the interval and it works only if fx is not continuous in AB. That means this condition is must be satisfied, then we can apply the bisection method. And the method requires a large number of iterations to obtain moderately accurate result. And here the most important thing is the order of convergence of bisection method is linear. Next we have some example. So first we have compute the real number, a real root of x cube minus 1.1 x square plus 4x minus 4.4 equal to 0. Correct to two significant figures by bisection method. So here function is this one x cube minus 1.1 x square plus 4x minus 4.4 and here interval is not given. So we have to find out the first interval. And how do you find out? Since we are going to find smallest positive root, so always we will start from 0 to 1 if it is not given. So after getting this, if condition satisfied, what is the condition? F of 0 into f of 1 less than 0. If condition satisfied, then we will take the interval. Otherwise, we will go for the next interval. How do you go? 1 plus 1 increment. So let's check. F0 equal to minus 4.4 less than 0. F1 is also minus 0.5 less than 0. So this one not possible. So we will go for next interval f2. F2 is 7.2 which is greater than 0. So root lies between 1 to 2. here. So next is table, formation of table. So n is number of iteration. N means the first value of the interval. Bn means the last value of the interval. So here, since it is 1 to 2, we will start from 1 and we will end it 2. So 1 to 2 interval, and the value is 1 plus 2 divided by 2. This is 1.5. And f of xn plus 1, that you will put 1.5 in the given function, you will get it, that is 2.5. So here, since it is positive value, so there will be change in positive one. That means just see that in the first row we have 1 and 2. For 1, that is here you have the minus value for 1, and bn for you will get the positive value. So here you will write plus sign, and it will be changed according to the condition, according to the problem to problem operation or sign will be changed. So for this reason, since for this point 1.5, here positive value we have arrived, so where the positive value it will be changed. So just see the 2 will be 1.5. So this one no change, because if he will get here negative value, so here 1 will be changed as 1.5. Since here positive value, so 2 is changed as 1.5. So 1.5, 1.25, then you will get again positive value. So again 1.5 will be 1.25. So in this way it will continuing. So after this, after third iteration, here minus value we have arrived. So here 1 will be changed as 1.0.26. Okay. Now your question will be up to how many iteration we will go. That is depend on the answer column. So first we have to check which one your answer column. Answer column is this one, the root. Okay. And here question is to find the root, which is two significant figures. See, two significant figure means we will which start from the beginning. So when last two iteration the value of the answer is near about same and the difference is very minimum, we can stop. Just see here, here 1.125 and here 1.125, this one, sorry, this one 1.1026, 1.094. So here difference are much more. We have 0.032 2 like this. So when the difference is very minimum, like 0.0, 0.001, 0.0001, so this type of difference when we arrive from the last two iteration, then we can stop. So after fourth iteration we have 0.094, then go for the again minus value we have arrived. So here 1.062, 1.094 we will reach. So again 1.1095 at the second iteration, sixth iteration, since here positive value, so here 1.125 to 1.1096 regarding this. So in this way we can see that here our interval 1 to 2. So after using this positive and negative condition, we have seen here interval is decreased. Actually, if the suppose here we have the root, but after using this bisection method, it will find just here interval is decreasing. So in this way you will reach the smallest positive interval, smallest interval where the root lie. Okay, that is our aim. Actually we are going to find the root, but basically we will not reach at the direct to the root. We will find the smallest interval where root is lies. So in this way we will find out the root. Okay, so just see that in the sixth iteration we have 1.1018, in the fifth iteration we have 1.1095. So also we can write after, also we can finish our iteration process in sixth iteration also. Okay, if somebody will write the next iteration also, they can do, but you can stop also in sixth iteration. Okay, so the answer, we have to fix the answer. How do you fix the answer? So after getting this two iteration, when the difference is minimum, so we can stop here and you will write 1.1 is the correct root of the equation correct to two significant figures. So this way we can simplify the bisection method. We can describe the bisection method. We can find the root by with the help of bisection method. So this is the process to finding the root. Next, another example we have. So here also uh, just see, find the positive root of x minus cos x equal to 0. Up to 5 iteration it is given. So here some option we have where we can fix the number of iteration. So same way, since in interval is not given, so we will start from 0 to just see that here we have right here 0 to 0.5 also we can take. So must be which is from 0. So 0 to 0.5 both are minus value, so here we go for the 1. So 0.5 to f of 1 less than 0, this is your interval. So 0.5 to 1, this one not. So same way we will start, just see the first iteration. For 0.5 we have the minus value, and for 1 we have positive value. So here positive value arrived, so positive value change. Again here negative value arrived, so negative value change. The negative value arrived, negative value change. Positive value arrived, positive value change. Negative value arrive, so negative value change. So since here fixed in 5 iteration, we will stop here and just see here the answer is 0.07219. So after 5th iteration we have the answer. Okay, so also we can here correct up to 4 decimal places or 2 decimal places, that is your wish. Since here is not given, so but from your end you will find here 4 decimal places if you want to write. So 4 decimal places means 1 2 3 4 5. 5 decimal places we have to check since it is greater than 5. So that's why your answer will be 0.7422. You can write correct to 4 decimal places. This is your actual answer. Okay. So this is the bisection method, and this way we can find out. Okay, so till then, bye bye all of you. Next day we will start with Newton adaptation method. So bye all of you.